This video is a review for Unit 3, Quiz 1. So in the first problems, we need to put the equation in function form if necessary, and then graph. Remember that function form is y equals mx plus b. It helps us identify our slope in front of the variable and our y-intercept, which is the number by itself. So number 1, we already have it in y equals 5/3 x minus 4. So our slope is in front of the x, 5/3. Our y-intercept is the number by itself, 0, -4. When we go to graph this, we always start on the y-axis. So we're going to start at -4 on the y-axis. Our slope always tells us to go up or down and then to the right. So because it's positive, we go up 5 and then right 3. So from -4, I'm going to count up 5, right 3, up 5, right 3. And then I run out of space so I can connect those points and add arrows at both sides of the line. Now we have -4y equals 12x minus 20. So it's not in y equals, so we're going to divide everything by -4. So y equals -3x plus 5. So our slope is -3, which we can write as -3/1 to remind us there are two directions to go. And then our y-intercept is 5. So we're going to start at 5 on the y-axis with a slope of -3/1. We need to go down because it is negative and then go to the right. So at 5, I go down 3, right 1. And then I'm going to continue doing that across the graph until I run out of room. And then we can connect those points and add arrows on both sides of our line. Next, we have 6y equals 9x. So in order to get y by itself, we're going to divide by 6. In our calculator, 9 divided by 6, math, enter, enter, gets us a fraction of 3/2. So y equals 3/2x, which is our slope, 3/2. Because there is no number, our y-intercept is just 0. So we are going to start at 0, 0. We're going to use the slope up 3, right 2 across the graph. And then we can connect our points with arrows. In number 7, in order to solve for y, first we're going to subtract 11x from both sides. -3y equals -11x plus 66. We can divide by -33. Y equals 1/3 x minus 2. So our slope is 1/3. Our y-intercept is 0, -2. So on the y-intercept, we start at -2. If our slope is 1/3, that goes up 1 and right 3. And then we can connect those points. Now we are going to work the other direction. So we want to identify the slope and y-intercept and then write the equations of the line. So first we have this table. If we look at the change in y, each of these numbers is adding 10 to get to the next number. Our x's are changing by +2. So our slope is 10/2, which reduces to 5. The y-intercept is where there's a 0 in the table. So we have 0, -20. So when we rewrite this equation, we would have y equals 5x minus 20. In number 9 on our graph, the line is falling, so we're going to have a negative slope. So I'm going to go down first and then to the right. Down 4, right 6. So we have -4/6, which gets us -2/3. The y-intercept is where we're crossing the y-axis. So that point is 0, 4. So when we rewrite the equation, y equals -2/3 x plus 4. Next, we want to determine, are the lines parallel, perpendicular, or intersecting? So remember, to be parallel, that means the lines need to have the same slope. To be perpendicular, they need the opposite reciprocal, which means that one number is positive and one is negative, and the fractions are flipped. Otherwise, they are just intersecting. So in number 10, the first equation is y equals -1/4 x minus 7. So our slope there is -1/4. In the second equation, we're going to solve for y. So first, we're going to subtract 2x from both sides. 8y equals negative 2x plus 40. Then we can divide everything by 8. So y equals negative 1/4 x plus 5. So our slope is also negative 1/4. Because they have the same slope, that means these lines are parallel. In number 11, we need to solve both equations to get our slope. So in the first equation, 3x plus y equals 9. First, we're going to subtract 3x from both sides. Y equals negative 3x plus 9. So our slope here is going to be the number in front of the x, which is negative 3. In our second equation, we need to solve for y. So negative 12x plus 4y equals negative 12. We can add 12x to both sides. 4y equals 12x minus 12. Divide everything by 4. Y equals 3x minus 3. So our slope is 3. So while these are opposites, they are not reciprocals. So it cannot be perpendicular. They're not the same, so it can't be parallel. So these are just going to be intersecting. We can also compare tables from or rates or slope from a table. So in the first table here, when we look at y, we are going from 5 to 14, so we're adding 9 each time for y. If we look at the x's, we're going down by subtracting 3. So our slope is 9 over negative 3, which reduces to negative 3. In the second table, the x's are changing by plus 5. The y's are changing by plus 15. So we would have 5 over 15, which reduces to 1/3. Remember that negative 3 can be written as negative 3 over 1. So these are opposites and reciprocals. So our lines here are going to be perpendicular. In number 13, are the lines parallel? We can kind of see that one line is heading towards the other, so they're not parallel, but we also want to show that mathematically with our slopes. So if we look at the slope of the first line, we went down 2 over 7. The second line, though, went down 3 over 7. So the lines are not parallel because the slopes are not the same. In 14 and 15, we want to find the x and y intercepts. So in order to find the x and y intercepts, we can split this equation by rewriting it with each variable. So 4x equals negative 12 and negative 3y equals negative 12. To solve for x, we can divide by 4. So x is negative 3. So we have negative 3, 0. In the other equation, we can divide by negative 3. So y equals 4. So we have 0, 4. We can do the same thing again here. 5x equals 30. We can divide by negative 5. So x equals negative 6. Negative 6, 0 is our x-intercept. For the y, 6x equals 30. Divide by 6. So y is 5, 0, 5. In 17 and 18, or 16 and 17, they're already graphed for us. So to find the x-intercept is where it's crossing the x-axis at negative 3, 0. The y-intercept is 0, 7. For 17, our x-intercept is negative 5, 0. Our y-intercept is 0, negative 8.